So to find average velocity, we need 2 times. This is just saying over the first second of movement. So that actually means go from the beginning when time was equal to 0 to when time is equal to 1. And we need to substitute both of these numbers into the function to find out how far it traveled. We'll take a quick look at the graph to have an idea of what it looks like. So make sure that the mode is in radians. Y equals sine plus cosine of 2x. And then have this go from 0 to 2 pi. That should take care of one cycle. And then a sine plus a cosine, well, the biggest each one of those gets is 1. So this would probably range from -2 to +2. And then take a look at the graph. Nice, a bumpy curve. So it's saying when time equals 1, it was at this height. At the beginning, it was at this height. And so it dropped down, but the question is asking how fast did it drop down on average. So we need to substitute the two values into the function to find out the two heights, and then subtract those two heights. And the directions say this is in feet per second. So that's going to be the average velocity. And then we need to substitute a 1 in there. So sine of 1 is in radians because it doesn't say 1 degree. So we need to find out how much is sine of 1 plus, and then substitute a 1 in for t over here, cosine of 2. At 0, I'm going to change this to 3 decimal places. So it's a 0.425. And then substitute a 0. Well, that means that it's sine of 0, which is 0, and cosine of 0, which is 1. So if you combine those, it becomes a 1. And the bottom is 1 minus 0, of course. So this is still in feet per second. And then finally we've got the numerator is 0.425 subtract 1. So it's negative 0.575 feet per second. So it's traveling about a little more than half a foot every second, but the negative says that it's going down. And sure enough, as it goes from here, the beginning, to when time equals 1 right here, then that would be going down.